talk about functional programming, I will explain you functional programming on the way I explain it to my grandma. So I hope you are new in functional programming, because it's really for beginners. And I think if you try to learn it, you face some issue, because functional programming can be difficult to understand when you are too driven by mathematical ideas. So I will start by introducing me. I'm Charlotte Cavalier. I'm dev advocate at Coding Game. Who knows Coding Game? No one? Okay, just one. I just do a quick introduction. Coding Game is a contest. It's a website for contest of programming. If you want to challenge yourself and you want to try your skill on programming, you can go on Coding Game and fight to other developers on a challenge. But my main function is to work on Tech.io. Tech.io is our new website. It's about knowledge sharing platform. If you know something and you want to share it to other developers, you can create some interactive hands-on on our website. And it's on this website that I will do the live coding session. So you can follow me on my Twitter at CavalierCH, and you can have a look on my GitHub account if you want, on CG Charlotte. I'm a real tech lover. I spend a lot of time to learn some new technologies, some new thing. And I'm a game lover. It's why I love coding games so much, because I can mix the two. And most of all, I love my grandma. So this is my grandma. She's nice. She's really an awesome person. She really cares about others. And she's an amazing cook. Every time I go to her house, I have an awesome free lunch. His specialty is an Algerian plate called la coca, with a kind of tomato pie. But she's connected, pretty. She got a Facebook account, she got a computer, she got a cell phone. So she's not totally disconnected of IT, but she has no scientific background. So sometimes when she asks me what I do all the day long, it could be a little bit complicated to explain to her. And what happened a while ago. I was at her home waiting for my free lunch, and she asked me, "What are you working on?" So I tried to explain her. So I told her, "So you see, Granny, I'm currently working on my new presentation about functional programming." Functional programming is a kind of way to design program. It's pretty old, in fact. It has been invented in like the 70s, and it nearly has disappeared after that for like 30 years. And we start to talk about it like in the 10 past year. But it's still difficult to understand, and people are facing some issue to learn it. So she reacted to that, and she told me, but if it has been forgotten, and if it's difficult to understand, why do you want to talk about that? But I told her that I think that functional programming could solve some really, really modern problem. So I think functional programming can help us with concurrency and scaling issue. And it's at this moment that I understood that I have done a mistake, because instantly she asked me, what is concurrency and scaling? So I explained to her. So you see, when you are cooking, you put your tomato and your onion and your paper on the pan. And on the same time, your oven is heating. And on the same time, you are making your pastry for the pie. You do all the things at the same time. It's what we call concurrency in IT. We want to do things in the same time. But when everything will be ready, you will put your pie on the table, and everyone will be able to take a part without waiting for the other. And it's what we call scaling. It's what we want to do in IT, because right now, everyone has a smartphone, everyone is on the web, and we want to access things on the same time, and we don't want to wait for pages. So she was a bit surprised. She told me, but you already know to do that, because when I'm on my computer, I can access to Facebook, I can play with card, I can be on Skype on the same time, so you, the IT guys, are already able to do things in the same time. Yeah, we can do that on different programs, but in one single program, it's difficult, because we got some side effects. Imagine, you put your pie in the oven. You put the oven like 200 degrees for 180 degrees for like 20 minutes, and you go away. I'm hungry, and I want a pizza. I will put the pizza in the oven, and I will put the oven to 200 degrees. I will eat. But when you come back to get your pie will be burned. It's what we call side effect. It seems funny when I told it to my grandma, but it's what we do all the day long. All the day long, we are modifying some variable of our program. You are modifying some data structure. We put some element in some list. We are cleaning the list. We are changing field on an object, or we are trying to catch the exception of a web service who doesn't respond. We are writing some log in some file. All those things can create some side effects, and it's why functional programming can be really useful, because one of the great bases of functional programming is the notion of pure function. Pure function is based on two main sides. First side, if you give the same parameter to a function, you will always have the same result. If you do 2 plus 2 in mathematics, it always be equals to 4. It's never be equals to 5. And we want this kind of comportment when we create some program. And the other big point is a pure function shouldn't change its environment. So we will try to take away. When you go on the URL I give you, you arrive on TechAO website where I put some sentences about what I just told. And you have all the executing parts. So it's a function who has a huge side effect. I got a build URL function. We should create the full URL from a parameter. And it affected to a variable. We should not do that. It's a dummy example of things that we should not do. We don't want some sharing state. So the first time I pass in the function, build URL, it's okay, because I really have HTTP / the URL. But the second time, I got 2 HTTP, because I got a side effect. So I don't want to do this kind of effect, so I will just remove the affectation. But the interesting part is that in Scala, we don't want to use this kind of variable. Var is a mutable state. We don't want to use mutable data. We want to use values data. So we will change the var to the val. And this time, it should be OK. So we don't want to have sharing mutable state. So why the notion of pure function is important? Because we don't have some side effect. But as we don't have some side effect, we don't change other things. And when we do some program, we want to change things. We want to change our data in your database. We want to exchange with some web service. But we do that in some layer. Our business layer must be pure functional to not have side effects. And so it could be really easier to manage concurrency. The other good things to pure function, it's you have some clearer code. I have been maintainer for a long time, and when we pass some time to debug, to look why a variable has a weird value, it's really boring. So pure function can help you to have more stable program. The second core notion of functional programming is high-order function. In functional programming, we say that high-order function is a first-class citizen. Obviously, when I turned to my grandma, it was a first-time citizen. She sang about this kind of citizen. It's not that kind of citizen. Told that a function is a first-class citizen, it means that a function can be affected to a name. It can be the result of a function, or it can be the parameter of a function. It has exactly the same capacities than the other member of the language. So we can do an example. An higher order function allows you to pass another function in parameter. So I have defined a function called hello, who can say hello to a name. But I want to define a function, hello or xname, who will say hello if the name is defined, or it will say who are you if the name is not defined. So we will just define the greetings function. So it's a name as a parameter with a string and a function. I put the scalar function for passing function in parameter just upstairs. So I want a function who will take a string as a parameter and we will return a string. So to format it. And all this thing will return another string. So if the name is empty, I will just say, who are you? And else, otherwise, I want to apply the f function to the name. So it seems really simple, but it allows you to decompose the function. If tomorrow you want to have a function who will not say hello to someone and will say, I don't know, Guten Tag or Bon dia if you want, you just have to define another function and pass it in parameters. So it seems easy, but it's really, really useful with all the API collection. If you want to sort a function, you can just pass the comparator function in parameter. So if I want to sort alphabetically, I will just compare the elements. So I want the shorter the first, and I will just pass the list. The sort function will return the sorted function. So the reversal of alphabetically is nearly the same. I can just inverse the comparator. And if I want to sort by size, I just have to put the size parameter in the comparator. So it allows you to define some really clear function and parameterized. So it's the kind of functionality you will have with all the collection API for map, radius, everything. All you use in API collection is that. But those two functionality are the core of functional programming, but it's not all you need to know. There is three key tools that you have to well understand if you want to go further in functional programming. The first one is currying. Currying has nothing to see with Indian food. It's just a way to decompose some function. You have a huge function with multiple parameters, and you will decompose it to a series of partial application of only one parameter. When I learned that the first time, I don't understand why I should do that. But in fact, it allows you to design a better application with smaller function. I take an example. I got a multiply function, pretty easy to implement, x times y. But I want to define a multiply by 2 function. So I will just use my previous function, multiply, and I will apply 2 and x. So I will just decompose my application. Always, the first one is a dummy example, but if you want a real example, the second one, I want to calculate the area, it's okay, the area of a geometrical shape. I can define a function. We will compute the area for every shape. But I want to have a readable program, so I will define some partial application. So circular area is just the application of area with the radius as a parameter and math.pi. And if I want a square array, it will be the same, but with side by side. So I use this kind of syntax here because I love it, but not only, it's what we call pattern matching. I can define the definition of my function in function of the parameters. If I got a case with where y is math.pi, I will have one implementation, and otherwise I will have another implementation. So I will use it for the next exercise. The second functionality you need to manage, and I'm pretty sure you already done it, it's recursion. Recursion is just a function who calls herself until it go to its end condition. I'm pretty sure you have learned that in school. But what is great in functional programming language, we have compilation optimization, because recursion is really, really greedy in memory, because you will put all your intermediary steps, you will keep your results before the end in the memory stack. And at the end, you will compile everything. So you have a huge memory consumption. Oh, I already done the exercise. With the tail recursion optimization of the Scala compiler, you will not have that, because it will be like an iterative steps inside your computer, but you will think recursively. So you can define some recursion who will not be greedy in memory. So to use it, we are used to create an inner function with an accumulator to keep the intermediate results inside something. And we will, at the end, with this condition, you will just return it. We will just return the accumulator, so we will not lose some memory. So I can run it. So it's not greedy in memory. In Scala, there is an annotation at tail rec. It doesn't force tail recursion. It just verifies in the compilation that you have used tail recursion. The third tool that I want to present you is Lambda. I will not do some mathematics, but for us developers, Lambda are just inner anonymous function, and it's the way we want to use it. So let's try it. So you get an operation function we will take all the number from 1 to n and add it. So you can apply some function to each number. So you can create some sum, you can create thing. So I will just define some function like sum. We will compute all the number of all the number between 0 and a. For that, I just will use the operation function and pass a function in parameter. I is the limit, and the function will just be the identity function. We will return x for each x. But so I can define other function. We will use other operation and just define other. We just have to define other inner function. So for square, it's easy. X times x. And for some odd, I just want to add the number who are odd, so I will do that. So if x is an odd number, I will return the number, else I return 0. I think it should work if I haven't write anything. So lambda allow you to define some functions that you don't want, or I wrote something wrong, that you don't want to use later, or who are as easy to not giving them a name. So it should work this time. If I haven't done any other mistake, I hope. Yeah, it's working. So I have introduced you a 3 easy tool to use to go further in functional programming. But there is 2 awesome functionalities in functional programming which changed my life, and I really want to present it to you. The first one are the option type. Option type are a kind of wrapper who hide if there is something or there is nothing inside the box. It's a kind of Schrödinger cat of programmation. So we can use it right now. Option in Scala has 2 implementations. The first one is a none. If you don't have any value, you got the non-implementation. If you have a value, it's the sum implementation who wrap the data. So if you have some function inside, if it's empty, the option is a none. If it's defined, the option has a value. So just try to use it. I got the divide function. The divide function we will have a return if the divisor is defined, and it will return nothing if the divisor is 0. So I can match the parameter. So I will just put it. I will define amount and divisor match. And I will define the 2 cases. Case 1, I got nothing. So amount is anything, and if, I can just do that. And divisor is 0. So in this case, I will just return none. And otherwise, if I got anything else, I will just return a sum of the result, so amount divided by divisor. So I can test it. So if I want to use it, I can just guess if I got something or not and react if there is something defined or not. So the option has some nice method to allow us to use it. So I will just use this method who should return 0 if I divide by 0. So we call divide with amount and anything divisor. And I can get the value, and if I got the value, I return it. Or if I got something else, if I got a none, I will return 0. If I want to apply a function on the option, I just have the fold function, divide, amount, and divisor, and I can divide so, and I can, I think it's a map, or fold maybe. I can fold the data, and I will just apply it. I look, yeah, I got the value here. Yeah, it's fold. Okay, I will return -1 if I got nothing, because it's right upstairs. And if I got a none, I return -1. And if I got nothing, if I got data, I would just apply a function on it. So I can just return x by x. So this should work. Why it's good? Because you give some, you have a value for your null value. It means something. Oh, I've done something wrong. Yeah. There's our phone. Yeah, I don't know, I done a silly mistake. If you want to apply a function on your side, you just pass a function in the second parameter. Why options are good? It's because you can just give some meaning to your weird case. And sometimes we just return some null because it has no value. But in this case, we just define some meaning for option, for null value. So I love it. I love option particularly in Java because it's implemented in Java. So you can use it to manage your null pointer exception. So better than return a null, just define an option. The second type I want to present you is the future. And it's pretty easy to explain. A future, as I explain it to my grandma, it's something you wait and you can do something else at the same time. Real life example. My grandma wants to do a coca pie, but she has no tomato. So she will ask me to go buy some tomato. I go to buy it, but in the same time, she continues her recipe. She will cut the onion, she will cut the paper, put everything in the pan. And when I will come back, I will add, we can add the tomato as soon as we have it. So you can continue the recipe without the tomato. And it's what we want. We want to do some unblocking function. So just, yeah. Another example about future. I got this code. We will execute thing during the time the function getTomato will run. So just run it. As long the tomato are not ready, the function will continue to run. So you can do something. I'll just show you. But when the tomatoes are ready, instantly I can use it. So it's really useful with some map function, for example. If I want to use it, I can just use the feature I just defined. So I will declare a feature on this, and I will just map a function as soon to apply it as soon it's available. So I will just define a function. I think the function is if I got at least 4 tomatoes, x is greater than 3, I will return true, else I will return false. So as soon as I got 4 tomatoes, I can finish the pie. So it allows you to do some non-blocking programming. It's really easier to use than the Java thing with concurrency. You don't have to manage the synchronized thing, and you just have to use this with map and flat map. So thank you for attending this session. If you want to do the hands-on part, you can do it on Tech.io, and if you want the Coca recipe, you can have it now. And thank you for everything. You can follow me on Twitter, and you can find me on Montpellier Jug or Duchesse France. Thank you.